Welcome to the CAD Office training series for F.Connect for OpenBridge Modeler. My name is Heather Piorin, and I'm a structural engineer with WSP USA. In this video, we will be covering exercise 6.1 from the Bridge Design 3D Modeling and Plans course guide. This exercise demonstrates how to use the section callout tool to make pier sheets. Let's get started. First, we'll go over some background information that will help us understand some of the tools and processes that will be used in the exercise. This includes an overview of the dynamic view workflow, which will help us understand what the program is doing when we take our bridge model and develop model-centric plans. We'll talk about the Create Drawing dialog, which is one of the key parts of the dynamic view workflow that helps streamline the process. We'll also talk about FDOT drawing seeds, which are built into the FDOT Connect workspace to ensure that the tools used in the dynamic view workflow use FDOT standard texts and symbols and allow the user flexibility with other settings. We'll then work on exercise 6.1, where we'll first create a pier sheet including the plan, elevation, and end view, and then we'll move on to create a pier detail sheet, which will include both cap and column sections, and then we'll create a footing plan from our elevation view created in the first part of the exercise. I definitely recommend reviewing the lecture portion of Chapter 6 of the course guide, which is all about plans development. There's lots of good content about how to use various model types, the dynamic view workflow, and the tools that are used within it. While I will go over some of the basics, this is by no means intended to be a comprehensive overview. This diagram depicts a dynamic view workflow. You start with the design model on the left and work all the way to the right, where you'll end up with a sheet model that'll be included in the plan set. The design model will be the bridge 3D model or 2D layout if working in 2D. Once you have your design model, you could go through and manually create a clip volume or named boundary, but more often in OBM, we'll use either the section callout tool or place named boundary to facilitate the process. If using these tools all the way from the saved view to the sheet model, which is shown within the Create Drawing dialog portion, will be done automatically for you. Although, again, in theory, you could do all the steps separately. It's important to understand the steps that the Create Drawing dialog is doing for you in case there's any issues and you need to either start over or make adjustments. So again, more often than not, you'll use one of the dynamic view workflow tools such as a section callout to first define a clip volume or named boundary, and then create a saved view, then reference that saved view into a drawing model, and then reference that drawing model into a sheet model. We'll want to make sure that we adjust the scale and the placement of the drawing model within the sheet model, so we adjust the scale to make it fit on the sheet border. The sheet model will always have a 1:1 scale. So what that means is if you're working in an 11 by 17 sheet, if you measure the border, it will measure 11 inches by 17 inches. We'll want to make sure that we add the dimensions and annotations to the drawing model. That way, when any scaling happens or any movement of the drawing model within the sheet border, all of those annotations go with it. You can add generic notes and annotations within the sheet model. For example, notes where you'd want to see where exactly they're placed within the border. Regarding the scales, the reference scale for the drawing model will be 1:1, and the annotation scale will be adjusted to be whatever is needed to fit within the sheet. For the sheet model, the reference scale will be whatever is needed for the drawing model. It'll match between the sheet model and the drawing model. The annotation scale of the sheet model will be 1:1. Like I said, 11 by 17 should measure 11 inches by 17 inches. As a note, the FDOT borders should never be added as a reference or placed as a cell in the design model anymore. The border is set up to be automatically placed within a sheet model. This is a Create Drawing dialog box, which comes up when you use a section callout tool or others to help streamline the dynamic view workflow and model-centric plans production process. There's a lot going on in this dialog box, but we're going to break it down into the 3 sections. The upper section is for the saved view, the middle section is for the drawing model, and the bottom section is for the sheet model. In the saved view section, the first entry is for the name. This is the name of the saved view itself, as well as the name of the drawing model. The drawing seed is grayed out in this dialog box because it's been selected in the previous window where we started the dynamic view workflow. In the middle portion, the Create Drawing Model box is checked, which means we will create a drawing model from that saved view. Generally, this box will be checked. The seed model is selected automatically, and the annotation scale will be whatever the user estimates that it will need to be. This can be set initially and then can be changed later after you take a look at the sheet model and see how it fits. The annotation scale of the drawing model should always match the detail scale of the sheet model. In the sheet model section, there's a checkbox for Create Sheet Model. This doesn't always have to be checked. Sometimes you just want to create a drawing model and then you can manually add that drawing model to the sheet model later. However, if you'd like to do it at the same time, we'll check that box. Again, the seed model will be selected automatically. Under Sheets, by default, New will be selected. However, if you already have an existing sheet model that you'd like to send the drawing model to, you can select it from that drop-down menu and it will add your drawing model to an existing sheet model. The annotation scale of the sheet model should always be 1:1. Again, if we have an 11 by 17 plan sheet, it should measure 11 inches by 17 inches. The detail scale again should match what you have as an annotation scale for the drawing model. These are the available FDOT drawing seeds. The drawing seeds control various drawing model properties such as the display style of the saved view reference, whether it's hidden lines, solid lines, or wireframe. It controls the reference presentation setting, the clip volume settings, synchronized view settings, etc., and the detail symbol style, so the section callout arrows, the drawing boundary view titles, etc. In the FDOT workspace, these drawing seed files are numbered and grouped by tool, then display style, then orientation, and if the sheet number is included in the detail symbol style. You'll only see the drawing seeds applicable to the tool that you are using. For example, 00 through 08 are for the section callout tool, using either the FDOT solid, FDOT hidden, or wireframe display styles for either horizontal or vertical direction of the cut, including or not including sheet numbers. 11 through 15 are for 3D or 2D named boundaries using either FDOT solid, FDOT hidden, or wireframe display styles, or by view, which allows the saved view to control the display style. 20 through 22 are for the detail callout tool using either FDOT solid, FDOT hidden, or wireframe display styles. To get started, we'll open up the 6.1 Begin DGN. We'll confirm that we're in the FDOT workspace within our dataset workset, and then we'll go to Browse. We'll find our 6.1 Begin file. We'll click Open. This file contains the bridge model that was completed in the Chapter 5 exercises, and we want to create a new DGN file where we can house the Pier sheet. So to do that, we'll make sure that we're in the OpenBridge Modeler workflow within the FDOT tab, and then within Actions, we'll click Create File. So unlike the DGN that we used for the 3D model, we're going to use, for file group, we're going to use substructure sheet files. And that'll bring up different file types. So we'll scroll down to be pound Pier for the sequence. Will be 01, and we'll have no modifier here, and we'll let the file sequence be 01. You can see that the output folder is structures, and then we want to set the county to Pasco if it's not already selected, and then we'll let the coordinate system be what it is, and then we'll want to confirm that the seed file is the FDOT OBM structure seed 3D. It looks like it is here, but if it was not, you could go to Browse, and then you could navigate to that seed file. Double check all of the other inputs are good, and we'll select the Create Open File button. You can see in the background it's closing the 6.1 begin file and opening this new file that we created. We can go ahead and click Close here. And this is a new file, there's nothing in it, so we'll go ahead and reference our 6.1 begin file, which is the completed bridge model. So to do that, we will open up our references dialog box, which I have docked at the bottom, but if you don't have it docked, within the Home tab in the primary group, you can select Attach Tools or References. Within the reference dialog box, we can click Attach Reference, and then we'll select the 6.1 begin file. We'll click Open, and then within our reference attachment dialog box, we will make sure that the model is selected as default and that live nesting is on, that the display overrides are set to allow, and then we'll change our nesting depth to 1. Click OK. Now back in our view window, we can click Fit View. That's up here at the top. Click Fit View, and now we can see as our in our view window that our reference is shown. So the annotations, as you can see, are very small, so we'll want to make sure that we change the annotations. So we'll open up our Properties window. In my case, it's already open and docked, but if it wasn't, within the Home tab in the primary group, you could select this Properties button. So if I clicked it, it would close, and we'll click it here. We'll have it open. Next, we'll open the Models dialog box. So again, mine is docked down here, but if it wasn't, within the Home tab in the primary group, select Models. So with the default model selected within our Properties window, we can now change the scale. So we can set the annotation scale. We'll select the drop down here, and we'll scroll down, and we'll find 1 inch equals 30 feet. So you can see now the annotation scale has adjusted, and the tick marks and text are visible. Since we're creating a Pier sheet, we're going to go ahead and turn off all of the superstructure levels. So again, I've got my level display docked, but if you didn't, in the Home tab, in the primary group, click Level Display. This is our reference here, so we can go ahead and click our reference. We can click the plus sign, and then we can toggle off some of the levels that we don't need. So we're going to turn off all of the superstructure levels. So we'll sort them by name to make it a little bit easier, and then we'll turn off through the bearing pad. We'll keep the bearing seat on. We'll turn off the core levels except for support lines. Turn off comp group beam, and then we'll turn off the haunch concrete, and then we will also turn off the sidewalk concrete. Alright, those levels look good. We'll make sure that we save settings. You can either click it up here or on your keyboard you can click Control F. The next thing that we're going to do is rotate the orientation of the view so that the x-axis and the y-axis run along the width and the length of the footing. So the way we can do that is we can go into the Utilities tab here, and then this ACS group. We can select Define ACS by points. So you can click the little drop down here and select Define by points. Alternatively, you could use a keyboard shortcut where you type R and then type A. Now that we've got our ACS axis here, we're going to snap it to the bottom left or the southwest corner of the footing. You can see it's snapping it to the footing. I'll click once to set where my axis is, and now I'm controlling where the x-axis is oriented. So I'll go ahead and click the other corner of the footing here as my second click, and then my third click will be in the upper portion of the footing here. That way I've got the x-axis oriented along the length here and the y-axis oriented along the width or the transverse dimension. So I'll do my third left click here, and we've now defined our ACS. Within our view toolbar here up at the top, we can click this drop down menu here, and then we can click top view. Now, because we've defined our ACS this way, when we select top view, it'll give us this unrotated portion of the pier. Alternatively, to the view window, you can also hold down Shift, right click, and then type T for top. So the first thing that we're going to do in terms of creating the sheet is to open up the section callout tool. So instead of being in the OpenBridge modeler workflow, we're now going to go into the drawing workflow, and then we're going to go into the annotate tab up here, and then within the detailing group we can click section callout. When I click section callout, this place section callout dialog box opened, and we can select our drawing seed. By default, none is selected, but if I click the drop down, you can see that 00 through 08 are available because these are our section callout drawing seeds. For this sheet, we're going to select 04 FDOT hidden, and then we're going to place our section callout. So we are going to, I'll use multi-snap 1 here so that I can select on the support line here. My first click I'll have outside the width of the pier on the support line, and then you can see now that my second click will be defining the direction. So I'd like that to be the other side of the pier on the support line, outside of the pier. So this is my second click. And then the third click, you can see, defines the direction of the section callout and the depth. So for that, we'll just go outside of the pier. We'll go ahead and left click to define that. And now we've got our Create Drawing dialog box. So we talked about this before. This is the Saved View section. This is the Drawing Model section. And this is the Sheet Model section. In the Saved View section, we'll go ahead and type Pier 2 Elevation. We've got our 04 FDOT hidden drawing seed already selected, and then our seed model is also selected. We'll go ahead and select annotation scale for the drawing model to 3/16 of an inch equals a foot. And we will go ahead and match that to the detail scale of the sheet model. 3/16 of an inch equals a foot. For the sheet, we'll let it be new since we don't have any sheet models created. We'll make sure that this is 1-to-1 here. And then we'll let it open up the model after we click OK. Double check all of our settings. They look good. We'll click OK. So you can see that we've now opened up the model here, the sheet model. So we had the default model, and then the section callout tool created this drawing model and created this sheet model. You can see that the full length of the piles is shown right now, and we don't need that, so we can go ahead and adjust our clip volume so that the piles are shortened. So that's one way to handle it. Another way, you could just do a clip boundary, since at the end of the day this is just a reference, but we'll show the methodology for adjusting the clip volume. So we'll go back to our default model. In our models dialog box, we can double click default, and then we'll go ahead and rotate around so that we can see our 3D clip volume. So we can go to the view rotation here, do rotate view with the method of dynamic, and then we'll just rotate around. So left click and hold, rotate around. Now that we can see the section callout down here, we'll go ahead and click the section callout, and then you can see the 3D clip volume here. When you're selecting that section callout, that'll be down at the 0 elevation, which is the same place as the decor levels in the support line. We're going to go ahead and move this section callout up by 100 feet in order to let us bring this bottom handle to where we need it to be on the piles. So by default, since we place our section callout on the 0 elevation, we can't bring this handle up more than or above the section callout. So that's why we need to move the section callout itself. So we're going to select the section callout, and then we're going to use the move command. So within the drawing workflow, in the Home tab, under the Manipulate group, we'll click Move. So when it says Move Element here, you know that that's been selected. So we can go ahead and click a location here to start the Move command. And then you can see down here in my AccuDraw that if I click or if I key in 0 for X, tab over to Y, 0 for Y, and then tab over to Z and select 100 feet or enter 100 feet for the Z direction, click OK. And then if I left click in my view window, that will confirm the move of that section callout up 100 feet. So I can right click to get out of that move command. And then left click away so that the section callout is not selected. So now you can see that we've moved this up. So we can go ahead and rotate the view again by going to View Rotation and then Right View. So once we do that right view, you can kind of see the front view of the pier. So we'll go ahead and click the section callout again, and we'll bring this handle up just below the footing, and then we'll find the top handle, we'll click it, and then we'll bring that handle down to just above the pier cap. So once we've adjusted this clip volume, we can go back to our sheet model and take a look. So within the models dialog box, if you've got it docked, you can go there. If not, you can go to the primary group and click models, and then double click the Pier 2 sheet model. You can tell that it's a sheet model because it's got this little sheet icon next to it. You can see now that we no longer have those very long piles shown here. We've just got our pier and the shorter portion of the piles. We do have to move this reference though, since it's outside the border, we want to move it to the proper location. So now within our references dialog box, if you've got it docked, you can access it directly. If not, in the primary group, you can click the references here. Again, everything is a reference, so if I click on the reference here, you can see that the boundaries are highlighted, and you can click Move Reference here, and then you can click within your view window and just move your reference to the bottom left corner. We've now got our reference in the location that we want, and we want to also move our title here, our drawing boundary title. So you can click the drawing boundary title, and then within the Home tab in the Manipulate group, select Move again, and then we can move this title to where we'd like it, so kind of centered between the two footings. Now that we've got our elevation view, we're going to create another view using the section callout tool without the annotations. So we'll add that within our drawing model. Within the Models dialog box, we can double-click the Pier 2 elevation drawing model. So you can see that's a drawing model with this separate symbol, this gray symbol rather than the sheet model. If I double-click that, you can see that we are now in our drawing model with our gray background. We'll go ahead and open up the section callout tool again. So within the drawing workflow, we'll stay in that workflow. We'll go into the annotation tab, and then within the detailing group, we'll click section callout. So we'll keep the drawing seed as 04 FDOT hidden, but we're going to be placing this in the drawing model, so we're not going to be able to see the annotations anyway. For our first click, we'll go above and to the right, so left click. Second click, we'll bring this all the way over to the left, and then in the top left, we will have our second click, and then our third click to define the direction and depth. We'll have it be just within the columns. So now I'll do the third click. Now we've got another Create Drawing dialog box here. Within our Saved View section, we'll have the name be Pier 2 Plan. And then we'll want to make sure that for the annotation scale for the drawing model, as well as a detail scale for the sheet model, that we select the same scale that we used before. So 3/16 equals a foot. We'll go straight down to the detail scale of the sheet model and select the same scale. 3/16 equals a foot. Now, unlike the original Create Drawing dialog box that we entered, we will go ahead and for the sheets, rather than being new, we can use that drop down and we can select this Pier 2 elevation sheet. So this will send a drawing model of the pier cap to the same sheet model that already exists. So I'll go ahead, double check all my other settings look good, and we'll click OK. Now you can see that when I clicked OK, it dropped the plan view in the middle of the sheet border. So that's fine. Again, this is all just references, so we'll open up our references window in the Home tab, in the primary group, and click References. You can see that each of these two views has its own reference, and the model name has a description. We've got our Pier 2 elevation and our Pier 2 plan. We'll go ahead and move our Pier 2 plan to be in line with our Pier 2 elevation. So within the references, we'll select the Pier 2 plan, we'll select Move, and then we'll go ahead and line up the corner of the plan. So we'll select the corner here with our snap, and we will snap to the corner and the elevation view, and then we'll just go directly up from there. All right, that looks good positionally, and we will go ahead and move the drawing boundary title as well. So we'll select that in the manipulate group, click move. You can also drag and drop it just as a note. We'll move that up, and now we've got our drawing boundary title there. I'll go ahead and shift this over a little bit, just drag and drop to be kind of centered. The next thing that we want to do is to add an end view. So we will do that similarly in the drawing model. Within our models dialog box, so if you've got it docked, you can go there. If not, in the home tab, in the primary group, click models, and then we can double click our Pier 2 elevation model and add another section callout. So again, staying in the drawing model workflow, in the annotate tab, in the detailing group, we'll open up the section callout. In this case, rather than the 04 FDOT hidden, we will use the 00 FDOT solid for our drawing seed. So we'll go ahead and select the bottom right corner here as our first click. Our second click we can do in the top right corner. And our third click will go ahead and encapsulate the entire pier. So our third click in terms of the direction and depth will be on the outside of the pier. So I'll do my third click now, left click, and we've got our create drawing dialog box again. So just as a note regarding that depth here, in our case, since the footing elevations were the same, we went ahead and just encapsulated the entire pier. You will have to play around with your case and see if you've got different elevations. It might end up with some additional lines that maybe you don't want. So you can adjust that clip volume afterward if needed. So for the name here of the saved view, we'll call it Pier 2 End View. Our drawing seed is FDOT solid. And then again, we'll want to make sure that our scale, both annotation scale of the drawing model and the detail scale of the sheet model, are set to the same 3/16 of an inch equals a foot. 3/16 of an inch equals a foot. And again, for the sheet, we'll go ahead and click the drop down and we'll add this new drawing model reference into the existing sheet. We'll go ahead and click OK. And again, it's dropped our end view in here, but it's put it in the center. So this is just an exercise in moving references. The home tab, then the primary group, references dialog box, you can see we've now got another reference. And again, because of the naming of our model, we know that the end view is the one that we want to move. So we'll do the same process where we select move reference and we use a reference point on the pier cap. We can use either the top left, top right, it doesn't matter. You can go ahead and snap there. And then we can snap to the corner of our elevation view, and then we can move this end view over to the right. We'll leave some space for notes if needed, and we will move our end view title here. So we'll click that drawing boundary, select move, and bring this in the middle here. Now that we have everything in order, we'll go ahead and change our drawing boundary names to be more in line with what we would use in plans production. So you could double click this to change the title. However, the proper way to do this is to select the drawing boundary, and then in the properties, so in your primary group, you can open up the properties window and then change this to plan. If you hit tab, it should process. Do the same thing for the elevation. You can just delete the Pier 2 portion, or you can retype elevation, hit tab, that'll process. Same thing with the end view. We'll click that drawing boundary, go into the properties dialog box, and we'll have it just say end view. And we can tab to have that process. All right, looks like we've got our sheet set up. So you'll notice that there are some elements that are missing in the plan view. These can either be drawn in live within the drawing model, or it can be brought in with additional references to the model. So that would be like our center line, bearings, beam lines, anything like that. You can add your annotations in terms of dimensioning in the drawing model, and then you could add any notes needed in the sheet model, and then you could adjust your border information using the FDOT Plan Set Manager tool. Now that we've completed the pier sheet, we can start working on the pier details sheet. As a note, if you did not want to see this bottom line here, which represents the left footing, since it's at a different elevation than the right footing, you could adjust the clip volume that's used for this end view. Rather than encapsulating the entire pier, you could have it only go through to the right footing, and that would eliminate that line there. So the first step in creating our pier details sheet is to create a new sheet file. To do that, we'll make sure we are in the OpenBridge Modeler workflow. In the FDOT tab, we'll open up the Create File tool again. We'll keep the same discipline as before, structures, the same file group as before, substructure sheet files, but instead of the B-pound pier, we'll use the B-pound pier det. For the bridge sequence, it'll be 01, no modifier, and we'll keep the file sequence as 01. The output folder is structures, and we'll confirm that our seed file is FDOT OBM structures sheet seed 3D. So that's correct. If it was not, you could browse to the seed file location and select it. The county is Pasco, and the coordinate system will come through automatically. For the action, we'll go ahead and delete this. This is basically creating a blank sheet model, but we're going to create that sheet model as a part of the exercise. So we'll go ahead and click Create Open File, and it'll create the new sheet file. So the B01 Pier det 01 sheet file that we just created is open. This is a blank file here, there's nothing in it. This is where we're going to eventually build our pier detail sheet. However, we're going to use a section callout tool in the pier sheet itself that we just completed, because we want to see the annotations from the section callout. So what we'll do is we'll go back to the pier DGN. So there's a couple different ways you could do that. You could actually down here click back. That would bring you to the Pier 01 sheet, or you can go File, Open. You can select from your recent file here, or you can go to Browse and navigate to that file. So I'll go ahead and open up the B01 Pier sheet, and we can get started on our section callout. So to get to the section callout tool, you want to go in the Drawing Workflow, in the Annotate tab, in the Detailing group, we'll click Section Callout. For the drawing seed, we're going to select the 05 Hidden No Sheet. In the course guide, it uses the 07 Hidden Vert No Sheet. However, we're going to use 05 since that's more appropriate for the horizontal section callouts. The first one we're going to place is in the constant portion of the column. We'll click to the left of the column, left click to define the first point. We'll left click again on the right side of the column, and we'll have this section pointing down. So we'll go below our section that we just defined, and we'll click again, left click. So we've just defined the section callout, so it would like us to name the saved view. So we'll call this section AA here, and we'll have it create a drawing model. We will, in this case, we'll click next to file name. So previously we did not check that box, and by default it'll create your new drawing model and your new sheet model in whatever file you're in. So in that case it was our Pier sheet. However, you could alternatively send your drawing model and your sheet model to a different DGN file, which is what we're going to do now. We're going to browse to the file that we just created, Structures, Pier DEET 01. So that's where I'm going to send my drawing model, and we'll click for the Create Sheet Model. That'll be where we send the sheet model as well, or where we create a new sheet model, Pier DEET 01. For our scale, we'll go ahead and use the same scale as our Pier sheet. That will likely be too small based on the scale here, but we'll practice changing and adjusting our scale after placement as well. So we'll take a look at all of our settings. They look good. Creating a new sheet model. All right, we'll click OK. So yep, it looks like our scale is a bit too small since we're going to want to be drawing rebar in here. So we can go back and we can adjust the scale of the section, and then we'll go back and adjust the annotation scale for the drawing model as well as the detail scale of the sheet model. So first we will change the detail scale of the sheet model. So to do that, we'll open up our references here. We will click on our reference for section AA, right click, go to settings, and you can see here that we can adjust this detail scale from 3/16 of an inch equals a foot to a 1/2 inch equals a foot, and that should be a more appropriate scale. So we'll click OK, and you can see that that scale adjusts. After we adjust our reference scale, we'll want to make sure that we go in and adjust our annotation scale as well. So to do that, we'll open up the Models dialog box, and we'll make sure that we have first our Properties window open. So mine is docked to the side, but if you don't have it docked in the primary group, you can open up the Properties there. Then we'll go to our model, and we will select our drawing model, so the one with the gray symbol here, and then with our properties window open, we can adjust the annotation scale to match. So 1/2 inch equals a foot. Alright, now that both of the scales are adjusted, we can go ahead and move this section over here to the top left to make room for additional sections. We'll open up our references and we'll simply move this reference over. So you can click your section AA reference, we'll click move, and we'll just move it more or less in the top left corner. And then we can move this drawing boundary title as well. So to do that, you could drag and drop it, or you could click it and go to, in the manipulate group, go to move, and kind of just center this on our section there. If this were a real production sheet, obviously you would be a little bit more careful about your placement, but for our purposes of stepping through the exercise, we can just kind of eyeball it. Alrighty, we've got our section AA drawn, so we're going to work on our next section. So we're going to reopen the Pier file by going File, Open, and selecting B01, Pier 01. Alright, so we will do that same process in the drawing workflow in the Annotate tab in the Detailing Group section callout. We'll use 05 again, and in this case we're going to locate the section in the tapered portion of the column. So we'll go slightly below the pier cap. We will click a point to the left of the column. Again, point to the right of the column. And in this case, we're going to practice using the AccuDraw toolbar. So we're going to have, right now, it is locked, but in case it's not, it's locked on the horizontal, but in case it's not, we can key in here for the Y axis, enter 0, and then hit enter. And now you can see, even if I move my cursor up and down, it's going to lock on a horizontal line there. So we'll go ahead and left click again to end the portion of the section callout that defines the cut. And then in this case, we will also have the section looking down. So I'll define that depth and direction. We're going to go back and change that depth to 0 later, so it doesn't really matter where you end that snap. It's more about the direction. So we'll go ahead and left click again, and we've got our Create Drawing dialog box. For this section, we'll call this section BB, and then we'll set the annotation scale as the adjusted scale that we know it needs to be, 1/2 inch equals a foot. We'll go directly to the detail scale for the sheet model and match it. And then we'll use the same detail sheet as our destination for the drawing model. In this case, we're actually not going to create a sheet model, so I'll unclick this. We're doing that so that we can practice manually adding a drawing model reference to a sheet model. So I'll go ahead and click OK. Everything else looks good. And it's going to open up that drawing model with that section BB. So we're going to now go to our sheet, which is the one that has sheet in the bracket here for the model name. And you can see we've only got section AA, but we can bring in section BB. So to do that, we'll open the Models dialog box. So you can go into the Home tab and open the models here. You can see we've got our drawing model for section AA and our drawing model for section BB. What you can do is just click and hold section BB drawing model, drag and drop it into the sheet model within the view window here. So I'll let go of that click and drag, and I can go ahead and use the recommended attachment method. That's fine. And now it's going to want me to click to place that section. I'll just place it anywhere within the border because we're going to move it. And now we have our section BB placed. We're going to do the same process where we first move the reference and then move the text. So I'll open the References dialog box, and you can see we've got section AA and we've got section BB. So we'll select section BB, we'll click Move. You could alternatively right-click and select Move that way. We'll go ahead and just line this up with section AA, move it over, and then in this case we can just drag and drop this, but you could use the move command like we did for section AA, and again for this we'll just kind of eyeball it. Alright, so now that we've got our two column sections set, we can go ahead and start working on some pier sections. So we'll go back to our pier sheet and cut some more sections. In this case, you could go File Open, but I'm just going to click back here, back again, and we'll find ourselves in the sheet model of the pier file. So we're going to go ahead and in this case we're going to create a working line to help us make sure that our pier section is right at the middle of the column. Alternatively, you could use a tentative snap to do that, but we're going to use a working line. First, we're going to change the level in the attribute section to a non-plotting level. So we'll select a non-plotting level, and then we'll place a smart line. You can select it in the placement group, or you could spacebar, get your pop-up menu, and click Place Smart Line. So we'll snap to the center of the footing here, and then we'll just draw a line that is directly above that, and we'll have it be outside the pier, just so we can use that as a guide for our next section callout. So I'll left click to finish drawing that line, and then I'll right click to get out of the Place Smart Line tool. We're going to access the section callout tool again. So in the drawing workflow, in the annotate tab, in the detailing group, we'll click section callout. In this case, we're going to go ahead and use the drawing seed 07, which is the FDOT hidden vert no sheet number. So we're doing a vertical cut now, so that will orient the text the way we need it. We can now place our first point for the section, so we'll place it above the pier. Our second will go below the pier cap, but in a way that we can still see the text here for the annotation. So we'll left click again to define that point, and then we'll go ahead and define our direction. So we'll look to the left in this case. Click again, and the Create Drawing dialog box opens, and we'll call this one Section CC. We'll make sure that our file name is B01 Pier Deet 01. We will, in this case, we'll let it add the drawing model reference to the existing sheet model. So we'll set our scale, 1/2 inch equals a foot, 1/2 inch equals a foot, and we will, instead of having it create another sheet, we will, for new, we will, instead of it being new, we will select section AA. So we'll have it added to our existing sheet. Alright, we'll double check that all of our entries here and settings look good, and we'll click OK. Alright, it's added another section here, so we'll go through that process again. Go to our references, see section CC. We'll go ahead and move that again. We can line it up. And then we can click our section here, move, we'll place that below our section. Alright, we've now got our section AA, our section BB, and our section CC. So we'll create one more cap section in the tapered portion of the cap. So we'll go ahead back to our pier sheet. And we'll do another section callout. In the Annotate tab, section callout, we'll do 07 again. And now we will place our section in the tapered region. So we'll left click to start defining it, and we will left click again at the bottom, and then we'll go to the left of that section and we will left click again to define the direction. In our Create Drawing dialog box, we will call this section DD. We'll go and change our scale to match. 1/2 inch equals a foot, 1/2 inch equals a foot. Confirm that we're sending this again to our Pier detail sheet, both the drawing model and the sheet model. And for the sheet, instead of creating a new one, we'll select the existing one. That all looks good. We'll click OK. And it'll bring us back to our Pier detail sheet. So again, we'll go through the process of moving over the reference, section DD, click Move, line up the top, move it over a little bit, and then we'll grab that text and move it as well. All right, this looks good, but we are going to go ahead now and adjust the depth so that we no longer see these kind of like depth lines here. So to do that, we will go back to the Pier sheet, File Open, B01 Pier, and we'll adjust the clip volumes. We'll start with this 4 here, which represents section DD, and you can see that we've got both a forward depth and a back depth. There's a couple different ways that you can adjust this. You could either, in the Properties window, you can adjust the back and front depth here, or you could manually use the handles. I usually like to key it in so that we know for sure it's 0. But if you wanted to use the handles, you could click here, this Move Forward clipping, and you could snap it to the section callout. You could do the same with the back depth, snap it to the section callout, and you can see these values have changed to 0. So we'll go through and do that for all of the sections, and we'll enter 0 here for back depth, 0 for front depth. You can see that the handles adjust when you change the values there as well. And our last one for CC. Properties, we'll key in 0 for both front and back. So now you can see none of our sections have depth, and once we change that, then our sections on our Pier detail sheet will adjust dynamically. The next thing that we're going to do is have these callouts here. Rather than using the numerical values, we'll have them use the section letters. So the place that that is controlled is actually in the drawing boundary itself. So we'll go back, File Open, into our Pier detail sheet, and we'll go to our sheet here, and we'll click the title here, and that shows our drawing boundary, and we'll change our drawing identifier here from 1, we'll make that A, we'll do B instead of 2, and then we'll click C, change our drawing identifier to C, then we'll click D, we'll change our drawing identifier to D. So now when you do that, the annotations in the Pier sheet will adjust as well. So everything is linked dynamically, and you can see that we no longer have that depth there with our clip volumes. So our Pier detail sheet is good to go now. We'll go back into our Pier sheet and make a couple more adjustments for the annotations. Alright, so we can see here that the annotations now correctly show the letters. However, we've got this continuous line here, where in Florida we generally use a 2 arrows rather than kind of one continuous. So the way that you can adjust that is by clicking the section callout itself, and you can right click and hold on the section callout and select Create Gap. So this annotation is actually made up of 3 segments here. We've got the 2 arrow segments on the left and the right, and then this line in between. So because of that, we can actually use the snap for the tail, click once and click twice, snapping on the other side of the tail, and that's creating that gap between those two. Now if we click away, we've got that gap in there. We'll do that again for all of them. So we'll click on the section callout, right click and hold, and then create gap. Snap to where that tail is. Snap again. There we go. Do it again. Click the section callout, right click and hold. Left click create gap. Find where that tail starts. Left click once. Left click again where it ends. And one more time for section DD. Right click, create gap, find the tail to start the gap, find the end of the tail to end the gap. Alrighty, and now it looks like our pier sheet looks good. The last component of our pier detail sheet will be the footing view. So we are going to do that cut rather than in the pier sheet model. We're going to do that in the drawing model, and that's because we don't want to see the section annotations. So we'll go ahead and navigate to the Pier 2 elevation view drawing model. Within here, we can open the section callout tool. So in the drawing workflow, in the annotate tab, detailing group, section callout. So for this one, we'll go ahead and use the 04 f.hidden drawing seed. We'll click to a point more or less mid-footing, left click, and then we will go to the same elevation on the other side, left click again, and we want to point our direction of our cut down and make sure that it encapsulates the piles. So we'll go ahead and left click to end that, and we'll call this footing plan. We'll toggle to create a drawing model, but we'll unclick create sheet model. We will add that in manually again. For the file name, the pier detail sheet is fine, and for the scale we're going to use 3/8 of an inch equals a foot. Looks like everything else is good to go. We'll click OK. And it's going to open up our pier detail DGN in our drawing model that we just created. So you can see that the column does not appear in the footing plan view. So we're going to open up our references dialog box here, and we will click our reference. We can right click and go to presentation. Then our presentation window will change the synchronized view to presentation only, and then we'll make sure that the back depth is displayed because by default it is not. And then rather than from view, we'll want to use that FDOT hidden display style. So once I click OK, you'll see that the column now shows up here, and the column is not dashed though. So we can then do one more step, which is going into the display styles. So we'll go into OpenBridge Modeler Workflow. In the View tab, under Presentation Group, we'll open up in the bottom here We'll open up the display styles. We'll select FDOT hidden, and we will add the display rule rather than none. We can add the hidden column display style or display rule. We'll click hidden column, and then we'll close out this display style. Kind of zoom in and zoom out to adjust the view there to have it reprocess, and you can see now that the column is dashed. Now that we've got that looking the way that we want, we will add this view here, this drawing model, to our sheet. So we will navigate to the section AA sheet model here. We'll open up our model dialog box in the Home tab. Open models here, and we can see our footing plan. So we'll go ahead similarly as before. We'll drag and drop this into the view window here. Recommended is fine. We'll click OK, and then we'll just left click to place, and this location looks fine, but if you want to move it, you can open up your references, select the footing plan, right click, move this up if you'd like, and the same thing with the text. If you wanted to move that text, you could either drag and drop, move it, or you can go into the drawing workflow in the manipulate tab, click move, and move that text there. Alright, now our Pier detail sheet is complete. It's ready for annotations, dimensioning in the drawing model, and adding rebar. Thank you for watching this section of the training series for FDOT Connect. Additional training videos and course guides are available on the CAD Office Training webpage, which may be found at fdot.gov/CAD.